Uniform motion is a special case where the acceleration as a function of time is always zero. So if I were to draw that graph, I'd have a straight line at zero. Since the acceleration is the derivative of the velocity, that means the velocity as a function of time is some constant. Its slope is zero everywhere. So it could be some value, but it has to be the same value throughout. And since the position is the antiderivative of the velocity, the position is then that constant times t plus some integration constant, which is the initial position. Because x evaluated at 0 is the initial position, and if I plug 0 into this equation, I just get the integration constant. X as a function of time is the initial position plus the constant velocity times time. So be careful that this plain v here, we just use a v without subscripts or superscripts or anything else just for simplicity, but it represents just some number, whatever the constant velocity it is. So the position is also a straight line. It starts with some initial position, whatever that happens to be, and then it has some slope that is equal to the constant velocity. Be careful, you might have examples where the acceleration may be essentially zero throughout, but in different stages it has different values of constant velocity. So in this example, my acceleration is essentially zero throughout. However, I have two stages of constant velocity. It's not uniform velocity throughout this entire time span because the velocity changes from this first part to this part. But in each stage, it can be considered uniform velocity. So if I were to find the position function in this first stage, it would have some constant slope up corresponding to this value of the velocity. And in the second stage, it might have this slope down corresponding to this velocity. In each stage, the position represents a straight line, but it isn't uniform motion throughout, just in each stage. So if you wanted to find, say, the position as a function of time during this first stage, you could find that line. But if you wanted to find the position as a function of time in the second stage, you would have to find that line. So even problems where you don't have uniform velocity throughout, you might be able to break it up in stages where each stage can be considered a uniform velocity problem.